Calc BC, I wanted to talk to you about that Math Excel problem that we were talking about today in class, and it was problem number 26 on your 3.1 Math Excel. And the first answer that they asked us for, I don't know if you remember, but it was that. They asked us, it was an inversely proportion, that velocity was inversely proportional to the square root of s when s is the distance equation. And then the second question said find the acceleration, which we know is the derivative of that. So we said, well, that this was equivalent to k times s to the negative 1/2, and remembering that s of t is an actual function, right? And so when you've got some function to the negative 1/2 power and you're taking the derivative, you got to use the chain rule. So this would have been negative 1/2 k times s to the negative 3/2 times the derivative of s. So if we were simplifying this, it would be negative k times s prime of t over 2s to the 3/2. So that's what we got for our a of t. So there was our velocity, there's our acceleration, with s of t being our position function. And then the next one says rewrite the expression with s squared in the denominator. So this was part C. They wanted s squared in the denominator. This was part B. This was part A. And so we said, well, to get s squared in the denominator, we would have to multiply this by s to the 1/2 over s to the 1/2, because that would give you s to the 4/2, which is s squared in the denominator. So there's that, and then this became negative k s to the 1/2 times s prime of t in the numerator. Okay, so that was our answer to part C. And then part D was the one that I kind of got stumped on this morning, and so it said for part D, hold on 1 second, sorry about that. It said to substitute for s to the 1/2 and s prime of t, which, by the way, s prime of t is v of t. That was the main thing that I think, if you would have done that substitution, that we would have gotten it easily. I was thinking that it was going to have to be, implicit differentiation. But I don't think it did. I don't think that we needed to do that. But what we did probably need to do was realize that what is the appropriate substitution for the square root of s. So for that one, if you take this v of t and try to solve for the square root of s, you'd multiply by the square root on both sides. The square root of s times v of t equals k. And so the square root of s is going to be k divided by v of t. And so for that one, and this would have been k divided by v of t because I'm substituting it in right here. And then this is just my v of t because I'm substituting s prime of t with v of t over 2s squared. Look at this. The v of t's cancel. Negative k squared over 2s squared. I made it way too hard. And it was all because I think it was all because I didn't think of this right here. Okay? So anyway, I just wanted to tell you that you actually can do this problem. It's not implicit differentiation. All right,